Welcome to the Meltzone Podcast from May 2nd, 2020. This is episode 34, and I'm Tom.
And I'm Stefan. And on today's episode, we are talking about how I finally got married, even in these special times. Tom optimized his existing CNC router to enable it to cut aluminum, and he's going to tell us what he did there. I did a lot of tool changing and even a bit of tool dropping on my E3D Toolchanger over the last couple of weeks. We have a small correction about who is injection molding face shields over in the US. On the news, Adrian Bowyer has released a proposal about a continuous unattended 3D printing system where he basically puts a couple of solenoids below the printing bed and uses them to hold it in place and also heat it up. Then Tesla supposedly uses 3D printing as a quick fix to fix a couple of problems on their Model Y, probably in order to have a stopgap. Then, sorry, got a little bit confused. Then the Munich FabLab is working on an open source metal 3D printer that can use MIM pellets and extrude them in a similar way as BASF's ultrafuse material into a green part that you can later sinter, but at a lower price and open source.
Very nice. In further topics this week, this new setup is kind of weird because there is weird delays. In further news, the US Army has created a new type of 3D printing filament that uses ABS and polycarbonate, but in a way that is not typically done that way. Printabot, you guys know them. They were gone for a while. Printabot are at least getting back on track. And we tried to briefly talk about PTFE 3D printing by 3M. We failed to talk about it briefly. We talk about it somewhat extensively. But questions as always sent in by you guys. The food 3D printers that have been passed around, do they actually work? Are they actually something that contributes to the world? To use the words of Dale, who asked this one, our opinion on the new nozzle extensions, long nozzles by Nonplanar.xyz, and whether we are considering building a custom or a DIY 3D printer off of plans available from Thingiverse like the Hypercube, and why we haven't done so already. Also, this week, like I said, is a bit of a different setup. This is a live streaming from Stefan to me, so if you see some technical glitches, I'm sorry for that. We're still figuring things out, but because this is hopefully something that is way easier to produce for us, it's going to make our lives much easier, and it's going to make producing these episodes a lot more convenient, so we can pump out more of them and, waste less time on editing and do more of the fun stuff like produce these videos or these podcast episodes and regular videos. So thanks for sticking through this with us. If quality is bad, we'll be better next week. Stefan, congratulations on getting married.
Thank you, Tom.
Special times. How did it go? Was it enjoyable?
So I was successful. It was more enjoyable as I thought, because like the week before we got married, we actually were told that we were only able to go, like, just my wife and I, into the Standesamt. What's the English name for that again? I can't remember. So just 2 days before we had before the wedding happened, we called them again and just asked whether we are still able to get married or if something changed again. They told us, and you will also be able to come with 10 people if we are going like into the big ceremony room. So it was kind of nice. So our best man and best best woman. I don't know how you actually said it. But yeah, they were able to join us. Our parents were able to join us. Our brothers were able to join us. And it was really nice. We had, we didn't have a wedding reception, but still, weather was nice. Our wedding car was my old Vespa. So we did a small tour after we got married, and our friends were just standing next to the road like every kilometer or something like that, and greeting us, and actually even doing fireworks or playing the violin or something like that, which was really nice. So yeah,
that's nice.
We didn't have a big party, but it still was enjoyable.
Yeah, so honeymoon all done and taken care of. I saw you posted some videos of taking care of the chickens. That's your that's your honeymoon from home right now, right?
That's basically our honeymoon. I'm so happy that we went to Japan last year because I don't know when such a big trip will be possible again. So yeah, married. That's good.
Happy for you.
Thank you. I'm also happy that we were able to do that. And yeah, probably like a real honeymooner, just going somewhere for a weekend into a nice hotel or something like that. Maybe we are still going to be able to do that at some point later this year, maybe when things are not that critical anymore. We'll see. But yeah, as you just said, we really have it nice around the house, so we can also enjoy ourselves right here.
Yeah, because you guys aren't living in the big city where you're literally locked into like a 500 square foot apartment and just have 1 minute to look out. That's one of the nice things of living out on the countryside. You're not really affected by this entire shutdown.
But also, like, shutdown, it's not totally lifted for you, but are hardware stores again open in Bavaria?
I think they've been open for a week or two now. So hardware stores are, I guess, a bit more essential now, or at least considered more essential. But like stores that are, it started out with stores under 800 square meters, so about 8,000 square foot of just sales area were allowed to open up. But I guess that was not quite that legal. So larger stores now have to limit their size to be at 800 square meters, and then they can open up as well. So step by step, it's going back to normality. I mean, it's nice that stuff's opening back up, but at the same time, I'm just afraid that we're gonna have like wave 2 that's actually gonna push our healthcare system to the capacity at this time.
Yeah, we'll see. At least next time. I think for many it's just nice to have a little bit more freedom again. And since we all need to, are maybe a little bit more prepared, we need to wear masks, and there is disinfectant available, at least in many stores. Maybe that just slows down everything a little bit, and
it's better than nothing. But yeah, it's not perfect security yet. Yeah. But anyways, you guys have been getting enough of that topic already. Something else that happened today is actually my phone died. So please excuse the Google Assistant noise just now. My Xiaomi Mi 9T the screen just went black and didn't. Ever since this morning, 11:30, the screen was black. Phone's still working, but the screen doesn't display anything. So I'm now on my old G7 again. Tech.
Yeah, it's annoying, but if you're still able to retrieve your data,
I need my Google Authenticator stuff. that's the one thing that's going to be a pain to recover.
What's actually the Google Authenticator?
It's the one-time passwords or the one-time keys, these 6-digit codes. So two-factor authentication.
And
which everyone should be using if they can.
And you are only able to retrieve them if your phone is working. Okay. Yeah. But how could you do something like that? Can you do screen mirroring over USB, or how could you do that without a working screen?
I think somewhere I should have like one of those USB graphics cards, technically, where it's just a USB to HDMI converter, but it's an entire graphics card in there. I'm hoping that will work, just hooked up over USB-C with a bunch of adapters in between. I'll have to see, but otherwise I'll have to. And that's actually one of the most painful things to do if you're moving from one phone to another one. It's just all those one-time or Google Authenticator setups. It's because you have to go into recovery or go into every single sign-on and disable it and re-enable it.
And the thing is, even though your phone is still under warranty, if you send it in for repair, there is a very high possibility that all of your data is going to be gone if you get it back.
Well, they're probably just going to swap it.
Okay.
If anything. I'm thinking that's all that's going to happen, because repairing something, swapping the screen, like that's a bunch of labor, and the screen, it's an OLED screen, is not that cheap either.
Yeah. But actually my OnePlus, I think 3 died 2 or 3 years ago, and I sent it in to one of the OnePlus repair stations. I think that is located in Poland. UPS picked it up. They repaired it in Poland, and I had it back like 4 days later. And they really just swapped the mainboard on my phone. So they supposedly are doing it if it's worth doing.
We will see. Yeah, I did buy the D90 through Amazon, so I talked to one of the qualified technicians who, first of all, suggested I put the phone into recovery mode, and I was like, "Yeah, but I'm not seeing anything." So I did what they suggested. Right now, I don't know what state the phone is in, but yeah, it ain't working. No. We'll see. It's 9 months old, so it should still be covered in the warranty. And unlike in the US, we typically have 2 years of warranty. US has like 30 days or 14 days typically.
If you don't get Apple Care.
Yeah. But that's like one of the things that just shouldn't happen. Like if you have a phone that you rely on, and for me, especially when I'm traveling, I've got my tickets on there, I've got my Google Maps, I've got all my planning on there. If that just dies out on the road, like I'm screwed.
Yeah. Well,
I mean, I'm not totally screwed, but it's just going to be a pain from there on out.
Well, just 1 year ago, I really started having all of my flight tickets and things like that for business trips on my phone, and not anymore a physical copy of it somewhere in my bag. And at first I really got anxiety because I always was scared that my battery is running out. But I don't know, we were getting more and more used to that. We pay with our phone, we have our tickets on our phone and stuff like that. And if they then break down, we are screwed.
It's just a single point of failure. So yeah, usually when I'm out traveling, I do bring a laptop just so I can at least have my emails there if I find Wi-Fi somewhere, and that should take care of most of the stuff. But still, yeah.
I don't know what's actually gonna happen if you are at your terminal at your gate and your phone dies. Will they just print out a ticket, or?
We've had that happen in Chicago, right? When we were flying back, they actually printed us a new boarding pass.
Did they?
Wasn't it like, hey, you can't actually use the digital boarding pass in the States if you're flying internationally? Can't
remember
something
anymore.
Like
okay,
that.
Could be the case. Can't remember it anymore.
We were waiting at the gate to have that printed. So yeah, that if you have your passport, I think at least flight tickets and stuff is something that can be figured out.
Interesting. Yeah. So you actually locked yourself in your studio, and you were playing around with your CNC router.
Basement.
Well, no. So the dirty work is happening in your basement still, and not in your studio.
Yeah, so basically the 3 rooms that we have to talk about here. So first of all, the studio here is a separate building, separate location to my former studio. And the former studio is 1 room over in the basement of where I live. And that workshop room where I have my CNC is actually studio number 1. If you go all the way back, the very first setup you see, like, camera looking that way, and to the left behind it is where my CNC corner is right now. So there used to be 6,000 liters worth of heating oil in there. We took down the wall, and there's now an extra little cubby there that used to be the printer cave, and now it's CNC. And I think I'll put my mini lathe in there as well. So yeah, I've been working on CNC stuff. I've been working on CNC stuff. I have to repeat that twice because it's a different word in those sentences. Yeah, the CNC, SeeMeCNC, whatever, mill.
This is actually the CNC router that is in the wooden box with those V-shaped aluminum extrusions.
Yes,
Okay.
exactly.
So you had that for quite a while, like for 2 years or something like that.
Yes, and I've actually not been using it much because I was always like, this is kind of inconvenient to use, and it's not that good of a machine. And I did have the Mendel Max that was kind of converted to a mill. I did give that to a friend, and whenever I needed something milled, I'd just say, hey, you mill that. But now I did upgrade this CNC slightly. I did put some work holding in it because all the bed, it's kind of built like a 3D printer, more or less. The moving bed was just a flat piece of Delrin. No wasteboard, no ways to fix anything to that. So you had to tape everything down, which wasn't very secure. I added threads to that. I put a wasteboard on it. The end connectors that hold those V-shaped rails into the frame, I upgraded those to have 2 more mounting holes so they don't twist as easily. Just a bunch of things. I tried a bunch of different router bits, and I can now cut aluminum.
Cool.
Shut up, phone. I don't know how much of that you guys are going to be able to see, and if the camera is going to focus, probably not. And if you guys are listening in audio only, then you're not going to see it anyways. But yeah, it does cut aluminum, and I don't mean just smear it around. Maybe I'll get it to focus if I move slowly. I don't just mean smear it around, but actually cut. And this is like the cheapest rolled aluminum stock you can get, which is it's like caramel, basically. Caramel for your CNC, and it just not happy.
So what kind?
But it cuts well.
What kind of a router bit and what kind of a recipe have you been using?
So the guys from CNC, the Bob company,
not Italian
the guys
though.
Who make Bob. Yeah, they've actually sent me a single flute 1/8" router
Bit.
Very nice bit. They sent me 2. I don't want to use that for tuning stuff in because I'm just going to break it. So I've been using a cheap single flute 1/8" bit. And basically, if you go to AliExpress and you say, hey, 1/8" single flute, that's what's going to come up. And that has actually been cutting really well. I've been running it at around 15,000 RPM, 600 linear millimeters a minute, and about a 0.5 millimeter
Depth of cut.
Optimal load. No, depth of cut like 2 millimeters and 0.5 optimal load on like adapters. Cool. So, I mean, it cuts. It's a real. I'm a real boy. It's a real CNC. I think it's as little of a CNC as you can get by with. I think it's intended to be comparable to the Shapeoko, not the Shapeoko, but the same guys, the Nomad. Yeah. It's a very similar form factor. I think very similar capability. It cuts. It's not the most comfortable setup, but you can make aluminum parts with it.
But where basically the things that were, in your opinion, most important to get it working properly, was it really just stiffening everything up?
Yeah, stiffening stuff up, because you could really see. So with those V profiles, I think they're like 60 by 60 or something. If you just took your hands and slightly pressed on it, you could see that rotate by like 1 or 2 degrees. And if you have the router stick out, that's like 2 or 3 millimeters of deflection just with like slightly pushing on it. That helped a lot. And yeah, just getting the feeds tuned in to a point where they're actually reasonable. But of course, that's way easier to do if you know the rest of your machine isn't like acting up and ruining everything.
Are we going to see something from your CNC, your new experience?
Yes, next week. Cool. Next week. So no video upload this week, but there will be basically a rundown of what I did and what I did to get it working.
Cool.
This coming Friday.
Cool. Looking forward to.
Very nice. Yeah. We don't forget, we still have that steel CNC project thing that we should maybe talk about at some point.
I think you already started and tried a couple of things out on your CNC. It's something. Yeah, definitely.
Yeah, I do want to get a feel of like how much rigidity you actually need to cut through stuff reliably. Yeah. So yeah, that's one of the things I'm doing with the Sienci CNC. just seeing, okay, how stiff, how rigid does it actually have to be to cut aluminum reasonably? And then I might just put a piece of steel on there and see if it works and how slow I have to go and how much more I have to overbuild it. So,
do you actually know how much the Sienci CNC is?
They're not making it anymore.
They're not making it anymore.
So it was discontinued, I think, in September last year. They now have the long mill, which is a larger mill. I think it does scale up to like plywood size or one sheet of plywood or something. So yeah, so different concept, different mill.
Okay, so more something that you know from the Stepcraft CNCs, the Go CNCs, the how are they? The Shipoko and stuff like that.
Yeah, I think the long mill is more along the lines of something like a Shipoko capabilities wise. The Stepcraft and Hase and all those, I think, are a bit stronger and a bit more capable than that.
So lots of X and Y travel, but little Z travel. So more for really cutting just sheet parts, plywood pieces.
Wood, yes.
Cool.
I think that's really where it's happy. Yeah. So yeah, that's been my week. What have you been up to?
Currently I'm finally finishing or at least working on my like beginner 3D printer review of the Ender 3 Pro and the Alpha YSU30 Pro, because I wanted to get that out for ages.
Have Creality offered to send you the what is it, the 6 something?
Yes, they did. And I was kind of confused because they said, yeah, it's available now. And then I've seen no, it's not available now. They kind of want to do a Kickstarter on it.
Yeah, I think we've briefly covered that in one of the previous episodes, but yeah, it's on Kickstarter, and I think shipping is sometime mid this year. But of course, with everything going on, that schedule might change.
Is it already on Kickstarter?
I don't know. I've not looked into it.
How's it called? CR-6 SE.
6.
Well, it is an interesting machine, or one feature is really interesting, and that is the bed leveling with the strain gauge sensor, where you directly
FSRs, force sensitive resistors, right?
That is really interesting because we have seen that on Delta printers with the Duet effector head thing for 2 years or something like that, which is really cool because you really are probing the bed. But we haven't seen it a lot in 3D printers, besides I think the Ultimaker that also uses strain gauges or an inductive probe. I think the Ultimaker uses an inductive probe that measures something in the print head when the nozzle touches the bed.
Ultimaker does something really interesting, but there are two different things that we're actually seeing. One is and it's two different parts as well. One is the strain gauges that are used on something like the Duet effector head, but the other one where you have those traces and you're basically stretching the traces and changing the resistance that way. But the other one is the force sensitive resistor that is like those little 1 centimeter diameter clear, basically like film buttons. Those. And I'm not sure if Creality is using those just under the bed or if they're actually using strain gauges.
Well, I have seen that, and they actually fix the cooling block of the hot end. They fix that to a cantilevered, like the thing that you see in a scale, to an arm that has a strain gauge applied to it, so that it really measures the force that is acting on the nozzle itself, which is kind of nice. I gotta give that to them if it's working. You still need to be sure that your nozzle is clean and things like that. But I think this is again a nice step into the right direction. Otherwise, it's the Ender 3 with a nicer screen. As far as I can see.
I was gonna say it does have a color touchscreen on it. Right. Well, we'll have to see. I got to look into that when if I actually grab one for review. But the entire Kickstarter thing is very strange.
The Kickstarter hasn't launched yet. It will launch on May the 6th. So, yeah.
Okay, so I guess they're planning on producing them now and having them ready for delivery once the Kickstarter is over?
I don't know. So, well, they're basically just using the Kickstarter as a marketing campaign. It's not for really getting funding. I think Creality doesn't need that.
No. Right. But getting back on topic, you've been tool changing. I've been tool changing in the CNC by hand. You've been tool changing automatically.
Yeah. So I think it was already, 3 weeks ago that I finally finished my tool changer with all of the 4 tool heads. And it has been quite a project. We have already talked about that last time, that I just needed to get used to working with Duet. The tool changer itself is quite of a complex system because you have 4 individual tool heads. And you really need to dig deeply in how is it working with tool offsets and things like that. But
tool offsets on CNC. Wow, that's its own pile of something that I'm waiting.
But I got it working, and I printed like a ton of settlers of Catan hexagon playing pieces, tiles. This was actually one of the things I wanted to do for ages with just a multicolor 3D printer or a multi-material 3D printer, and it has been working out really nice. With all of the tool changing, the process takes quite a while because you need to, change the tool head, reheat like the idle tool, prime the nozzle, and stuff like that. But it was working quite reliably, to be honest. I dropped a couple of tools from time to time just because, I don't know, something wasn't properly working and the offsets were not precisely tuned in. But yeah, it's an interesting project. I really hope to make a video about it in the near future, just because it's a nice concept, and if you have a specific application that maybe is not already like implemented in a normal 3D printer, just make yourself a tool and you have the possibility to do pretty cool things with it. You can use it as a vinyl cutter. You can use it with like a spindle on it to do additive and subtractive manufacturing with it. It's a project. It's not a fully working 3D printer when you buy it, but if you're into stuff like that, you can buy the motion system. Yeah. It's not a cheap machine, though.
I think that's one of the intentions with the tool changer, because it is such a complex product. They intentionally don't want to like oversell it as, hey, this is a 4 extruder 3D printer. No, you don't get the main board with it. You have to buy that separately, just to I think actually just to deter people from thinking this is something that's easy to get into. No, you have to configure this stuff yourself, and if you don't know how to do that, then you probably shouldn't get one.
But I hope to work with it more in the future, and we'll see. Multi-material, I don't know, maybe just only trying out which materials are compatible to each other. Can you print TPU on PLA or PETG? This is now the machine that enables me to do that really nicely, and I don't have to fiddle around with, did I prime the nozzle enough that all of the remaining PLA was gone, and things like that that you have with multiplexing multiplexing hot ends. So
and I do have my Prusa MMU2 here right next to me, still sitting on the studio table from the last video I recorded, and I'm not using that for multicolor just because of that issue. Hey, am I priming enough? Is it actually going to work? Like, all that is just a bit of a pain with these systems unless it's perfectly figured out, and for this machine it is not. But the tool changer, I think where that is really going to be interesting is once we have, we've talked about this before, once we have a software that can actually make use of different types of tools, where you combine FDM with subtractive, with whatever cutter heads or tools you want to put in there.
I'm pretty convinced that Fusion 360 is going to be there in the near future, and that's going to be probably one of the tools that you will be able to use to do things like that. So
yeah,
fingers crossed.
Yeah, on the topic of Fusion 360, yeah, I think that's one of the things that I forgot to mention that I did to get the Sienci CNC running. I switched from using Cam, which is a super simple 2D based cam, to using Fusion 360, and it's just it's so much nicer, and it's not even that hard to get into. Like the machine setup is trivial. Yeah. And the amount of capabilities it gets you with all the adaptive stuff and just the 3D preview and collision detection, and it is really nice.
I have also been using a couple of different like cam tools in the past. I started with, when I did my own CNC, with Vectric Cut 2D, which is a really simple and straightforward tool to do 2.5 dimensional routing, perfectly suitable for many applications that you usually do in wood. Then I used Estelcam. Estelcam also has a couple of really nice features. For example, if you're doing wood and you are milling inner pockets, it has the feature to cut more into the corner that you have play if you want to put another part in there. And this was one of the things I really enjoyed in Estelcam. But then getting to Fusion 360, you just can do everything. It's not as straightforward as Cut 2D, for example, but it's if you get around using it, it's really powerful.
Yeah, I mean, I guess what he's saying with the with having corners overcut, it's just Fusion is really separating the low level, hey, this is how I want to machine my thing, versus the high level, okay, this is what I want my part to look. It's kind of separating that into design and manufacture, which really makes a lot of sense, because those two workspaces do exist, whereas some tools kind of do a bit of both. Like in Estelcam, you could even like you could do some rudimentary drawing, I think, if I remember correctly. So yeah, because Fusion has those very capable tools in design already, the cam workspace can really just laser focus on, hey, how am I going to produce this thing out of my piece of stock as good as possible?
Definitely. Still, if anyone is getting into CNC routing and is usually only doing like flat pieces of material, flat pieces of wood, I can still highly recommend Cut 2D, because it's so simple to use, and it is definitely easier than Fusion 360. So if you're not that deep into Fusion 360, take a look at Cut 2D. It's a really nice tool and not too expensive. I think it's around $100 for the software.
All right. Cool. Right. Before we move on, there is one correction that I want to make about the I think it was last episode or episode before that. Injection molded, reusable, sterilizable brackets for face shields. I think I said that. Who was it? Filament company from the US.
Printed Solid.
Printed Solid, yes. I think I said that they were doing injection molded. That was wrong. It is SeeMeCNC. Those guys have the injection molded brackets for the face shields and have made those and have moved to mass production really quickly from having to print one at a time to being able to just injection mold one at a time. And the cycle time obviously is a lot less for injection molding than it is for 3D printing. Yeah. One of the advantages of having people who know their stuff and just having the tools available to, well, maybe not perfectly, but quickly make the parts we need.
Yeah.
So props to them.
Still, I have, again, last weekend, I have been printing another 200 face shields for our local initiative, because one of the reasons is that the 3D printed part is kind of nicer to wear than the injection molded part that some others are using around here. It's just nicer to wear and has this nice protection on the top. So there were a couple of people saying, okay, I would rather use the 3D printed part instead of the injection molded parts because it's nicer to wear. So yeah, printed another 200 on my mini print farm down in the basement.
Nice. So that was face shields. Yes, let's move into the news. So, number one, Adrian Bowyer is at it again and has put out a proposal for an unattended. So, 3D printing industry are calling it a continuous unattended 3D printing system. It sounds complicated, but it's actually a really simple idea. So, it kind of centers or circulates around the idea of having a detachable bed, and the Mark III is over there, so I'm looking in the wrong direction, where you separate your bed heater and your print surface. And now on the Prusa and many other machines, you have a magnetic coupling between that print sheet, that is PEI coated in that case, and the heater. And if you just regularly print something, you peel it up by hand, you just lift it up and that's it. So what Adrian Bowyer is proposing is to replace those permanent neodymium magnets with electromagnets. Solenoid, but solenoid isn't a solenoid usually an electromagnet and something that like clicks out with a moving part?
Probably, yeah.
so I'm guessing that would be a mechanical ejection at the same time as well. Okay. So driven by pulls with modulated power, smooth through a low pass filter. Yeah, but that's so. If it's really a solenoid, you would have a physical pin that shoots up and pushes the bed out, while also releasing the magnetic force, the magnetic field, and the kind of interesting turn on that is he's proposing to not just use the electromagnets in there to hold down the bed and to release it once needed, but also to heat it. So because it's just copper coils, you can send current through that and they're just going to heat up, right? They're going to waste power essentially, which is what a heater is. And you don't have to do any other active heating, any other resistive heating, which I think is more of a bonus because a heater element isn't really that complex or expensive. But yeah, just that it's the idea of you have a removable print bed and you have electromagnets that release it once the print is done. So yeah, what do you think about that? Is that something that could be useful?
It's an interesting idea. Well, helps you to remove the bed more quickly and maybe without the need of really pulling it away from the magnets. Yeah, I think it could work. I don't currently see that many applications, at least for
print farms. You're printing face shields,
at least for home users. Yeah, but on a print farm. But for needing it in a print farm, it kind of would only make sense due to the added complexity if you would then really automate it all the way that like a robot is picking up the print plate, because otherwise it's not that hard peeling the magnetic sheet away from the bed. But I think it's a nice idea.
It is one part in the completely automated printing. Of course, there are belt printers and there are other concepts, but I mean, I've thought about this before, and what it came down to is releasing it from the printer isn't that hard. It's really if you have an electromagnet, the ejection of the bed isn't that hard. You just you tilt your printer sideways, you turn the magnets off, and the thing just slides off. But how do you replace the bed? How do you put a new plate, print bed on there? You would need to have some sort of a magazine and a at least a grabber that replaces it onto your print surface, onto your printer. That's going to be the more involved part, I think.
Do you actually see any technical challenges with using a solenoid for heating the bed and also like holding it in place?
I mean, it doesn't sound intuitive to me to also use the solenoid for heating stuff. It's certainly possible. Of course, the challenge is again, I think that if it's a solenoid, it has the pin in it. The electromagnet, it reduces or increases, depending on how it's configured, its magnetic field by the current you send through it. So I guess if you use it for heating, you would have to at least send power through it the way that you're getting more magnetic strength out of the magnet, instead of just sending it backwards and having it released while it's trying to heat up, which is, defeating the entire point. But it could be doable, definitely.
Okay.
It's just that I'd probably just put a regular heater in there because really it's not a complex part.
Well, but the thing is, at which location would you put the heaters? You would actually need to put the heaters like in between the magnets, because you only want, you could put the heater above the magnets, because those magnets could even probably pull the print bed down through one of these PCB heater beds.
If we look at the Mark III, the magnets are embedded on the underside below the heating tracks in that bed already. So if we just have basically the Mark 52 or whatever it's called heated bed, and just have slightly larger pockets where instead of the permanent magnet, we have the electromagnet in there, I think it's just going to work.
Yeah.
Yeah, so the proposal is showing something like 25 magnets in there, which unless the electromagnets aren't that strong, I think is way too much.
But you want, it always depends on the size, and you also want your bed to be heated equally. So for this reason, you want to have a lot of them.
Would be appropriate.
I was just browsing through Knobhead's blog, I think 2 days ago or something like that. Because I have read that article where the first heated bed of Knobhead was linked, where he also just screwed a couple of resistors to one of these aluminum sheets just around the circumference. So yeah, I don't know. It is nice to have a really nicely heated bed, but if you have a heat spreader above it, which, kind of distributes the heat nicely, it can also work just having a couple of spots that are, heated in the end.
Yeah. Now, I did do that video a few months ago, last year, about how even the heated beds on a few different 3D printers actually are, how even the surface temperature ends up. And I mean, we've seen anything from almost perfectly even. I think the Prussias were kind of okay. They did have a few hot spots, but it was extremely clear that as soon as you have some sort of a heat spreader in there that is just aluminum conducting heat around, that makes such a big difference to how evenly your stuff is heated. Like the, I think it was the Ender the Ender has the aluminum bed, aluminum PCB and then glass on top. That just is nearly perfect. You get a bit of drop off towards the edges, whereas something that has no spreader like the BCN Sigma, it has the PCB that doesn't heat up evenly and then even has an air gap to the glass. That just is atrocious, where you have 30 degrees of difference between spots. And it still works. Like, prints still kind of stick down to that bed.
Yeah. Well, yeah. Still, I do have the experience, at least with my two Prussias, that if I print parts really to the outer sides of the print bed, I need to rise the temperature by around 5 degrees Celsius, for PLA at least, that they properly stick to the bed. So
it might just be that, yes, it's a larger part. And it does have more force just by being
maybe
larger.
I don't know. Maybe it's just maybe it's just the bigger part. But I don't know. Maybe it's also a bit of the drop off that you have at the side. So this could also be an argument of having a very equally heated bed, or at least don't have corners and something like that, where the temperature drops off and increases the possibility that parts lift off.
But still, back to the concept. I think my take is pretty much the same as yours. It's something that can definitely work, but everything around it is going to be the bigger challenge. Like, how do you replace the bed?
Yeah,
Getting the bed off is doable.
Yeah.
You could, I mean, thinking about it, you could probably even do something like you have the bed, you don't move it all the way forward during a regular print, and then at the end of a print, you move it that extra centimeter forward, and there's like just a hook on the bed surface that hooks into a mechanical steady piece, and as the printer moves back, it just rips it off. Like that can remove it, but even on a Prusa with the magnets. But then how do you get the next layer on?
Yeah, we'll see if that's going to be something that we'll see in future 3D printers.
I think a lot of the stuff that's being thrown out there is just so that nobody else is going to patent it.
Maybe, yeah.
That there's prior art published to the point where, if somebody ever patents it, like that's nope.
I think that is a pretty good point that you're making there. So, yeah, since Adrian Bowyer is like full in the open source mentality, it could be a case, even though it's some ideas might not be like totally ready for being implemented on machines or don't make 100% sense. But before Stratasys is patenting them again and just taking that idea away from us for the next 20 years, it's better to just publish something at some point.
Yeah. Exactly. It's also very practical. 3D printing in general. If you have to fix a car and if you want to bring your car to market as quickly as you can, Tesla is using FDM, actually pretty rough-looking FDM parts in their production Model Y. So there's an article on InsideEVs.com that shows that apparently there's been an issue with the mold of the HVAC, some HVAC box that they have just glued a 3D printed part onto. Looks like some sensor mount or something. It's cool to see 3D printing used in a production car. I mean, if it's being used by any company, I would expect Tesla to be the one. But yeah.
The question again is why they're using a 3D printed part, and why isn't Tesla able to spit out an injection mold in like one night and do this part injection molded? I don't know. What's your thought on that? Why 3D printing?
I mean, a mold doesn't typically just take a day, especially for a part that looks rather large. I mean, there's plenty of machining time in a mold like that. But also what I'm thinking is they just had a bunch of these parts already produced and didn't want to wait for the mold to arrive, or didn't want to, maybe they wanted to make a few hundred cars and just had that many parts queued up and needed a last minute fix. I mean, Musk is known for having rather quick or short deadlines on stuff, and hey, if you gotta meet that deadline, you probably would rather 3D print a part instead of waiting for machine capacity and for a mold to finish and then redoing all that.
Yeah, well, similar to face shields, it's just a stopgap. Probably we won't see that part in future models or in future just cars that are getting out of the factory. But if you use it on some of the cars just that they can get shipped and everybody's happy in the end, why not use it if it's working? The part really looks kind of crude, but probably somebody thought about if 3D printing is the proper technology for that application.
Yeah, it's on the outside of an airbox, so it's not really in contact with the air. It looks like works definitely.
The thing that I find really nice is that they are using FDM 3D printing, because you can see 3D printed parts in some consumer goods, but if you usually see 3D printed parts they're usually SLS 3D printed, so sintered out of nylon, which has a nicer appearance and the properties are more isotropic, and you don't have to worry about layer lines, you don't have to worry about supports and stuff like that. But yeah, either they were really, really in a hurry, or maybe they were using the same material as the airboxes. Maybe this is also ABS, and they can use a solvent to glue the part on the existing part. That might also be the reason why they were using FDM 3D printing.
That would have been my guess as well. Just the material they can use, because nylon isn't the material you can glue that easily.
Nope.
Yeah.
Cool.
So nice to see.
Nice to see. Yeah. And well, I haven't read the whole article, but it came out when somebody was just disassembling one for, I don't know, reverse engineering
for YouTube. No, just to show it up on YouTube, right?
Yeah.
It's what you do right now. You get a brand new Tesla, and the first thing you do is take it apart. Of course.
I actually want to get to that point someday where I can just buy I don't know how much a Model Y is, but probably 60, 70,
at like 40 grand or
40
something.
grand. Yeah, just take it apart and
I mean, I'm sure he's going to put it back together, and he's going to have a working car after that, but
Yeah. Cool. All right. Next news topic. So you have linked an article about FabMX, which is a Munich-based fab lab, and they are currently developing an open source printhead or printer for metal FDM 3D printing. Tell me more.
Yep. Tell me more. Well, you've been in contact with the guy.
So I have actually been in contact with that guy. So as far as I understand it, we have already been talking about metal FDM 3D printing a couple of times on this podcast. This is where you take a filament that is like 80% in weight metal and 20% just a binder that is holding the metal parts together, print a part out of it, and then remove the binder and center the part that you get like a finished metal part out of it. The thing is with that technology that the filament itself is pretty expensive. And
yeah, it's like the BASF stuff you can buy for,
the BASF,
what is it, $150 a roll?
It's the BASF Ultrafuse that is, I think, 120 or 150 euros per kilogram, but there are 3 kilograms on a roll, so you pay around 400 euros for a roll that is not even fully full in comparison to a PLA spool.
Oh, it's heavy, right?
It's horribly heavy. So what BASF is using is more or less their cutter mold pellets to generate the material. And BASF has been producing injection molding material for metal parts for many years, and this is used in so many like tools and stuff like that, where you also take pellets that are 80% in weight metal and then just a binder, injection mold them into your molds, deem binder, then sinter them, and yada yada. Well, the thing is, those pellets are way cheaper than the filament. I don't know how much a kilogram of cutter mold is costing, but probably like a fourth or fifth or something like that, in that range. So the thing is, the technology might be more feasible if the filament would not be that expensive. And the fab lab in Munich is trying to take away the necessity to use filament, and they want to use the pellets themselves to directly extrude them. There are already pellet extruders around, and I also have the Mahor pellet extruder. But the thing is, those metal particles in the pellets, they are abrasive. So you need to have an extruder that is capable of not wearing down when you put those pellets through the extrusion system. And this is what they are actually working on. So probably nozzles, an auger, and also the pipe. Probably
the feeder and everything.
The feeder that is out of hardened steel or something like that. And just to make that work. And if that's working in the end, Tom, are you still there?
Oh, hold on. My mic is disconnecting, reconnecting. That's not good.
Your mic is still there, but your picture is gone.
My picture is gone. It looks like my USB something just reconnected. I should be.
Yeah.
Am I back? I'm back.
Yeah, you're back. Yeah. So
my USB subsystem just crashed. Nice.
Yeah. So if they actually get it working, it would enable many more to use that technology. Well, it would be a step forward for that technology that it is more economic, because at the moment it's quite expensive to use it, especially also with the post-processing steps. But the material itself is also quite expensive, and So
I guess one thing that we should mention for this entire FabMX project is this is supposed to be open source. This is supposed to be built in a way where the community build their own machines and can use the processes themselves without having to invest in a I don't know, 20,000 euro printer, and then having to buy the proprietary material, and then having to buy the debindering ovens and buy the licenses for the processes, and I don't know what the steps are to actually get something like this working on a commercial scale. But instead, they're trying to do it in a, I don't want to say DIY, because there's still like high temperatures involved and all that, but at least in a setting where a fab lab can have a printer like this, and just have or give their members access. And the framework for this, it's the FabLab Munich. I actually do have a video of Andreas Kahler, who is one of the initiators of this project. I do have a video and interview with him somewhere on the channel. Don't look it up. It's old and the audio quality sucks. But it's based around the FabLab Munich. It's based out of that, and they're trying to make this available for everyone else, including other Fab Labs.
Cool. Yeah, I'm excited to see if it's gonna work out for them, because I think it's kind of challenging getting everything to work, getting constant feed, getting materials that will not wear down. And besides the UltraFuse, there are also other materials available on the market in pellet form that could be used for that process, and some don't really require that specific equipment for debindering debindering the material. Some can actually be melted or sintered in for example, in a dental sintering oven, something like that. So yeah, it might open up possibilities for some for this technology.
Very interesting. Yeah. I don't know. So Munich isn't that far away from me. Maybe I'll drive up there to talk to Stefan once they have something up and running, and once I'm actually able to leave this town again and venture out into the world. Very nice. And lastly, I think this one is one that we don't have. Well, lastly, there's still more to come, but the one that we both find kind of weird. News from newatlas.com and a few other companies, news sites have echoed this news as well. Apparently, the U.S. military is producing the U.S. Army is producing a type of filament that is ABS on the outside and polycarbonate on the inside, where it's not just one strand of filament that's just the same material through and through, but they have a star-shaped insert in an ABS sleeve, and apparently that gives you like uber properties for strength and stuff once it's extruded. I don't know how much there's to that. What I find really interesting is the way that they're actually making the filament. So they start with an actual slab of this stuff that's 3D printed. It looks like it's roughly like 3 centimeters in diameter, and it already has that star pattern on the inside. And it's kind of like it really reminds me of like candy making, where you make a slab and then you pull it inside, you melt it down, and then you basically stretch it.
How glass fibers are made.
Oh, glass fibers, yeah. So you started with an actual 3D printed slab. Looks like it's about 3 centimeters in diameter and like 20 centimeters tall, with the same shape, same pattern, polycarbonate on the inside, ABS on the outside, and then it's stretched in length into filament.
Yeah, so it would be really interesting to see what this material combination, or what the benefit of this material combination is, because we know PC ABS, filament, where PC and ABS is like directly compounded into one filament, but I don't know what the real benefit of having this star pattern in the material would be in the end. And I unfortunately haven't read the paper, which would be really interesting, but I have just seen that I might be able to like buy it for $8, and maybe it might be worth taking a look at it, maybe just to see if they also show a couple of the results, because I think they're saying in their abstract that it's 15 times higher in fracture toughness compared to as printed ABS structures, but I don't know how that compares to a PC ABS compound. That would be interesting.
All right, let me just look up if the internet does have. Oh yes, iHub still is up. There we go. I'm just gonna link that. We're not gonna link it in the where is it? In the show notes, but Stefan, there's the
Okay.
access. Or also, I mean, if you don't want to use Sci-Hub, actually one of the things you can do is just write an email to the researchers, and they're allowed to share the research paper with you without charging you. It's just the journals that are making the money off of papers. So yeah.
I'll be taking a look at it, and maybe we can talk about that process in the next video, and if it really makes sense to have a structure like that.
Yeah, especially once it's like smeared down as a layer. Like, does it actually? I mean, well, I would expect that star shape to be like slimmed down and then vertical and different.
Well, you compared it to rebar in concrete.
Yes.
But the thing with rebar is that you have two materials that have really different properties. So you have the concrete that is really really resistant in compression, and you have the rebar that also can take tension. And so the combination of both gives you the best of both worlds.
Yeah, and ABS and polycarbonate are quite similar in properties, so it's probably rebar is probably a bad comparison, but it reminds me of that.
So yeah, we'll see. I have. It might be interesting to take a look at the results, and maybe also, I don't know. You can 3D print your own filaments, so at least a small amount of that material would be able to be printable on, for example, the Toolchanger with two different tool heads.
So you're just going to be printing like little. I don't know how long you can print stuff that's like 1.75.
Well, you can. I don't know if you have seen the video of SeeMeCNC where he printed a spiral which is also hexagon shaped with different materials. Anyways, I think it was an idea of Basmia or something like that, right. Where you can print your own multicolor material by printing a spiral and then just stacking up different colors. And those colors will not mix up in the nozzle because you have a quite laminar flow all the way through the nozzle. And you get really interesting effects in the end. And I think that would also be I think that's a good idea. I think that would be also possible to just 3D print that on, for example, the Toolchanger, because you could also add different patterns that way. We'll see.
Okay.
Maybe I try it out.
Yeah. Let's see. All right. Good news. Not in the sense of good news, everyone. It's actually good news. So we've been following the story of Brook Drumm and Printabot on the podcast and on the YouTube channel. I did do a video interview with him just before the company went bankrupt, and just after the company went bankrupt. Did I? No, I don't think I have anything published before that. Anyways, it looks like they are back on track of being able to boot PrinterBot back up. So PrinterBot, US-based 3D printer manufacturer, and they were actually one of the first, or actually the first Kickstarter printer ever out there, with a, I think, $300 printer that was kind of rough, but it printed, and it was the cheapest, but by a long shot, the cheapest printer you could get. And they've ever since been, I don't know, I've liked the printers for being kind of workhorses. Maybe in the end they kind of went a bit overboard with the color touchscreen and having their own printer server and all that. But anyways, PrinterBot is on track of getting back up. The bankruptcy process is done, is over. It's finished. Brook is no longer personally, it seems like no longer personally liable for any damages done or any debts, and he's basically getting a fresh start. So that is good to see. And also it's going to be really interesting to see what comes out of PrinterBot LLC 2.0, I guess. Which direction that's going to be heading, whether it's going to be printers again or, I don't know, other stuff. So...
Well, you actually know him a little bit more, and it would be really interesting to see how he places himself in the current market, because when he started with PrinterBot, there weren't as many printer manufacturers around, and the market was probably not as saturated as it is today. And he was manufacturing most of his stuff in the US, which was probably one of the reasons why he got bankrupt in the end. But if he wants to...
It ain't cheap, yeah.
It ain't cheap. Well, he was actually manufacturing most of the stuff in-house. And you told me that they had their water jet cutter, they had reflow ovens, pick and place machines and stuff, things like that.
Yeah.
So it will be interesting to see where he's gonna place himself. Simple, cheap 3D printer. We have seen the belt printer. I think that was one of the last things that he actually showed off at...
I don't think that was a product that was actually made. I think that was a design produced or something. The printer belt?
Yeah, something like the printer belt. I think this was one of the last things that he showed off at Bay Area Maker Faire or something like that. I have seen it at some point. If he's continue working on that, because that might be an interesting idea, and there the market is probably not as saturated as with normal Cartesian 3D printers, or if he's going to do something totally different. I don't know if he can let his fingers off 3D printing.
Yeah. But either way, whatever he decides to do, I think it's good to have more players in the... Well, it might not be good for the players, but it's good for the customer to have more players in there. And I think it's also good to have different takes on things. PrinterBot has always been unique in their printers. The way they were built, the approach they took to things, even if it wasn't always like the best approach, but it was an impulse, and it was a direction that they were able to try out and see, hey, this works, this doesn't. And yeah, I mean, lots of good things came out of it. So yeah. Anyways, it's good to see that that process is done, it's completed, and Brook family and his partners can move on to new shores.
Cool. Yeah, looking forward to that. All right. Let's take a look at the time.
You've got the time. I've been recording a bit before we started.
Yeah, we are already an hour in. So maybe just shortly talking about the next topic I put in there.
Yeah, because we can do that.
So I put PTFE 3D printing in our show notes because, even though it is not a news topic, so maybe start from the beginning.
Yeah, you gotta prime me on this though, because the only thing I know about PTFE is it is a plastic and it gets kind of toxic if you heat it up too much, and it's kind of slippery. So that's like the three things I know about PTFE.
It's the slipperiest material I think known to man, or something like that.
I'm sure there's something nano that's better than it.
Yeah, maybe lotus flowers. So the thing with PTFE is and wait a second, PTFE is a thermoplastic.
Right. So it gets soft and it melts as you heat it up. In contrast to a thermoset, which cures chemically and then it just breaks down when you heat it up.
But even though PTFE is a thermoplast, it can't be injection molded because I think I read about that. I think the viscosity when you melt it just before degeneration is still that high that you can't really make something out of that. For this reason, all of the PTFE parts that we see nowadays are extruded, injection molded, or with some other chemical process.
I thought you can't injection mold it.
You can't injection mold. So extruded in a way that you have PTFE particles and you kind of really just mush them together in a way that you, for example, get your Bowden tube for your 3D printer.
So it's more like it's probably more similar to a sintering process.
It's very similar to a sintering process.
Force the stuff together, and in the end, it's something that's similar to a solid part, but yeah.
You force it together, and then you still need to heat it up that you kind of fuse the particles together. So the thing is, with those properties, and you weren't in the past able to really create very intricate structures with it, just because you can't melt it, so you can't melt it, so you can't, for example, 3D print it on an SLS machine where you sinter the parts together with a laser, because they just don't melt. They kind of degenerate before they start just fusing together. So 3M was contacting me a couple of weeks ago, and they told me about their process that they have already had on the market for a year or two or something like that, where they are now able to generate 3D printed parts out of Teflon, out of three.
Oh, and you actually have some there.
Wow. Yeah, I actually received one, I think, a couple of days ago. And the thing that is interesting about that process is that they are using an SLA process or an MSLA process, where I don't know how it really works, because the process itself is proprietary, but they probably have particles of PTFE in a resin that they then cure just as a normal 3D printed part, and then remove that binder, so the resin, and then sinter the part in the end. And this is kind of a really involved process, because getting the binder out of that part can be really hard, because you need to find the proper point before your just material is breaking apart again, when no binder is in the material anymore. And then you also need to sinter it to get to a fully dense part in the end. And it is kind of similar to metal FDM 3D printing, where you also debinder, so get the binder out of the metal particles.
I was going to say that. Why not just use FDM in that case? It sounds a lot cheaper and a lot more tried.
It might be cheaper, but I think since this is kind of an involved process, using SLA as a process just gives you the possibility to 3D print even smaller parts, and even with more details that might be interesting, for example, for the medical industry and things like that. This might be one of the reasons why they use that process. And maybe the binders that are used, the thermoplastic binders that are used in FDM 3D printing, mightn't be suitable for the process. So I just thought it was interesting, because we haven't seen PTFE 3D printed parts in the past, and I just know from my professional experience that they sometimes would be useful if you are working with really nasty chemicals, or mostly with really nasty chemicals. And also the application where PTFE was used at first was with uranium hexafluoride during the Manhattan Project, because the uranium hexafluoride that was used to enrich uranium just chewed away all of the pipes that they were using to just put that gas through, and PTFE doesn't react to that, so they were cutting the pipes in that. And this is also one of the reasons why I think Teflon PTFE is still under export control, because it can be used for uranium enrichment. It's really interesting.
Okay.
So it doesn't react to things, so it might be interesting for the chemical and the medical industry. And it's now a process that can be used. As I said, it's a proprietary process, so you can't buy the resin and do everything at home. But they are offering that as a service. But I don't really see that in a very bad way, because the sintering oven and the debindering process and stuff is probably that complicated that it would not make sense for just a normal company to have all of that equipment at their facility.
So it's not like with the BASF Ultrafuse where you print your own parts and then you send it in for debindering. It's actually just a like shaper or something. You send the CAD in and you get the finished part back. Exactly.
So it's interesting. It's really nice to see those parts, and they don't look in a way like crumbly or sintered. They just look like they have the surface of a PTFE Bowden tube. It's really nice.
Slippery, smooth. Yeah. Now, the one thing that obviously PTFE is used for in 3D printing is, where you need slipperiness. But of course, if you just want to print slippery stuff, you can use, what's the name? Igus's FDM materials, for example. And those, aren't trivial to print, but you can just buy the filament on a spool and print stuff yourself. So if you just need that, then, there are alternatives. But if you need the chemical resistance, like you said, then PTFE is probably the way to go.
And what Igus is also offering, they also offer that as an in-house process where you send your CADs to them and they SLS 3D print more complex parts for you.
Yeah, just sounded like you're sending your pet cat to them.
CAD.
Like, please don't put your cat in a box and ship it to Igus. I'm sure that they appreciate having a cat around, but I don't think it's too good for the cats to be shipped with DHL.
Petsovernight.com. I don't know if you ever played GTA 3.
No, I didn't. But apparently, back in like the 70s or something, you were able to order pets through Quelle.
Seriously? Okay.
Yeah, they had dogs, they had cats, they had horses even.
I would like to see a shipping container for a horse.
I learned that from another podcast, and apparently the cheapest one was the dachshund.
Okay.
The cheapest dog you could buy. I guess easy to ship. You don't need very tall boxes.
Well, everyone who still remembers GTA 3, there was one of the radio commercials there, and it was petsovernight.com, delivering little bundles of love directly to your door. And that website actually exists.
Is it one from Rockstar, or is it just a
it's one from Rockstar.
Okay. Nice.
Kittens, puppies, fish, rhinos, stomach parasites, vermin, whales, sharks.
Yeah, GTA is, I think, more of an art project than a real game at times.
All right. So if you guys are interested, or if you guys need like really chemically resistant, highly complex parts, check out 3M's website. But it's not going to be cheap.
Do they ship to North Korea?
Probably not.
I guess they would be interested, but too bad. Cool. I think that's the news and topics for this week. Are we ready to move on to some questions from the community?
Yes, we are.
Let's start with number 1 from Dale. One possible small subject for the next Meltzone. Do food, sweets, pizza, etc. printers work, and do they have anything useful to contribute to the world? That's 2 questions in one. So have you followed food printing? Have you seen those in action?
I have seen it in action. Never ever printed food so far.
Right. So, okay. I guess there's a bit of a range of approaches and products that you could call a food printer. Like, I guess technically a pizza robot, like pizza in a box that like has the dough and then puts sauce and cheese and toppings and stuff on top. I guess technically that's as much of a food 3D printer as anything.
It's an additive process, right? Yeah.
It's layer based. It's like it ticks all the boxes, and it's computer controlled. So yeah, I mean that's a food printer, and I think that is useful, and I think that does work. But typically, when you are talking about food 3D printing, you're talking about something like the Boccasini, which are more or less local to me. They're from Freising, which is like 70 kilometers away. So they are. I mean, they started out, again, with Printabot and a syringe extruder on top. And that's typically what you still see with what's going to be called a food 3D printer, where you have a syringe that's CNC controlled and lays down, I don't know, they started out, or actually MakerBot actually started out like that as well, with a cupcake CNC, with a robot for decorating your cupcakes with colored frosting. That's why it's called the cupcake CNC, right? But typically, a paste extruder that can somehow extrude liver pate or mashed potatoes or caramel, or anything that you can put into a syringe and it can push through the nozzle, and then you can make 3D objects out of that. And yes, that works. That works. The one big caveat to me is that it's always it's just a reshaping process, just like any other 3D. Well, I guess SLA technically not, but like an FDM 3D printer, you have your input material, and all the printer does is to put it into a different shape. And with food printers, like it's not a Star Trek replicator where you create food from scratch. You still have to prepare the food separately and then place it into that syringe, and then all the printer does is it reshapes it again. So if you want to define work as in does it create food, no, it doesn't create food, it just reshapes it. But it does have its applications. I mean, the Boccasini guys, I know they're doing like again, cake toppings, like wedding cake decorations. I think one of the applications was also maybe more of a hypothetical one. If you have senior citizens that like can't eat specific things anymore, and you just want to have like something that's shaped absent pears, yeah, just like little balls of something that has added nutrients, or is one type of food in a different shape, you can do that with a 3D printer. It's not like you can't do that with any other process. Like if you have it in the paste form anyways, you can put it into a mold and just do it like that. But it's a very flexible process that can reshape food into any CNC program path.
Maybe where I could see, well, yeah, definitely. Maybe where I could see an application in the future is maybe 3D printing meat, because kind of replicating a fiber structure, maybe that would be possible with such a layered process.
You are going to need a multi-material setup though, because if it's just a paste, like what is that going to be? That's just going to be minced meat. That's just going to be spam essentially, right?
Yeah, maybe you have, I don't know, a extruder that coats those small sausages coming out of the nozzle in a specific I don't know, coating that it gets more chewy. I also, don't see really like useful applications of food 3D printing at the moment. Useful in a way that it adds something. It adds something to
that you can't do with another
that you
process.
can't do with another
right?
process. It's a gimmick and can maybe make nice decorations and I don't know, pancakes with your face on it. But
yeah, the pancake bot, right? That's a food 3D printer technically.
yeah, well, I have a volcano
2D
heat bed on my Toolchanger. Just add a syringe extruder on there, and then I can bake my own pancakes on my Toolchanger. Yeah. I don't know, maybe this is something I might do in the future. But yeah, at the moment I see it as a gimmick. There are some small applications, but I don't know, maybe in the future we really have a Star Trek thing that replicates.
I mean, like I said, you still have that challenge of you need to prepare what goes in. It's a one in, one out process. There's nothing being replicated or produced. Or even processed. It's just a reshaping process what we have right now. And I guess if you have something like a printer that creates a meat-like or a steak-like texture, a steak-like thing, it's probably not going to be very similar to a 3D printer as we know it today. It's not just going to be an XYZ coordinate system. There's going to be more to that process to create that product than that reshaping process we have right now. And typically on an industrial scale, there are machines that that maybe do something that we would consider to be a 3D printer, but it's so far away from that core 3D printing process that where it's just more efficient to do it in a different way. I don't know if you've seen the gifs of Viennetta ice cream, that layer based thing being made where it's vanilla ice cream and then a layer of chocolate, and then I mean, you could 3D print that like sideways, right? You could do that in a printing process, but it's just way more efficient to do it in a just conveyor belt system where you drop each layer on top. And technically, that's a 3D printer as well, right? But it's not something we would define as a 3D printer.
You're right. Okay, shall we move on to the next question?
Yes, go ahead.
So Belvi, German, is asking, what's your opinion on the non-planar nozzle by Nonplanar XYZ? It seems like a super easy solution, but maybe too simple? Heat transfer over the entire length and nozzle height calibration come to mind. So the thing what he is actually talking about is a special nozzle for existing 3D printers that is just like 5 times as long. The problem with non-planar 3D printing, one of the problems with non-planar 3D printing is that the angle at which you can print is depending on the clearance around your print head. And this nozzle is trying to conquer that by just making the nozzle longer and have more clearance.
Okay, I just saw something that I didn't see in the pre-show discussion of this topic. Okay. So what I said before we started here is this is just a UBIS hot end. This is just a standard hot end that's been on a printer bot forever, which is about 1/2 inch thick and quite long. Where you have your heater at the end, and then you have whatever the original ones had, PEK as an insulator up top, and then just a nozzle on the bottom. It looks like what the nonplanar.xyz nozzle is. If you actually go to Nozzles on their site, it looks like it's an extension for your E3D heater block or E3D compatible block.
Exactly. It is really just a very long nozzle.
So it is actually a nozzle and not a full hot end.
But not in a way a long nozzle as it is with a volcano hot end. It is the part that is protruding out of the heater block. That is very long and is, I don't know how long it is, but probably something like 4 or 5 centimeters.
Yeah. I mean, yeah, I guess it.
I guess,
I guess.
but I think there's
No.
still the issue with how do you make proper G-code for non-planar 3D printing? And I still get like a couple of comments every week about why are you not doing non-planar 3D printing on your channel?
I think we've covered it on the podcast before. Yeah, I've tried it. Now, what misled me originally was it looks like there are two iterations of the same product on Nozzles.xyz or Nonplanar.xyz, sorry, on the website. The first one really does look like a UBIS hotend because it's just at 45 or 90 degree nozzle tip on the end. Whereas if you actually go to Nozzles up top and you look at what the ones are that you can buy, is they are much sharper nozzles. So it looks like it's not that 90 degree up top, but more like a 30 degree maybe, or 45 degree. So it is actually a very sharp nozzle that also doesn't have, typically if you look at, I've got a few nozzles here. Obviously, if I grab one, you guys are not going to see it. But if you look at a nozzle, there is the bore in the center, typically your 0.4, and then there is a flat spot around it that in E3D's nozzles, I think, is 2.5 times as wide as your nozzle bore itself. And that is there to actually give you a better surface finish, because if you just have that pointy bit, you are going to have very rough top layers. You're not going to get a very smooth layer extrusion, or you're not going to smush it flat. So that actually has a purpose. But of course, since that flat spot is there, it's not very good for doing full 3D non-planar printing, because obviously it's going to collide with your already printed pass. So that's also something that the
non-planar,
what's it called, Nonplanar.xyz nozzle is doing.
But so the finish of like the orifice is very similar to an MK8 nozzle that is used on most Chinese printers. They also don't have this 1 millimeter, usually don't have this 1 millimeter flat spot on many of their nozzles. As I said, it might be very usable for non-planar 3D printing, but still you require some way to generate G-code for non-planar 3D printing. And as long as that is not really existing, it's nice to look at. But
Stefan, there is that non-planar Slick 3R build that you can get.
Yeah, it's a nice start, but it's still...
Yeah, I've tried it. It's not it's not doing a lot. Now, of course, if you can set it to very aggressive settings with something like a non-planar.xyz nozzle, then it's going to do a bit more. But what they're showing on the website is probably hand-crafted, post-processed G-code. Wait, there's also a tab on software. Yeah. What do they have on software? In order to generate G-code from your design, you will need our G-code generator. It's a simple but effective tool to be used with Grasshopper and Rhino 6. So they are selling a $20 G-code generator with it. Okay. That works with Rhino and Grasshopper. And I think Rhino and Grasshopper is what... Oh, God, what is his name? Last year or 2 years ago on the FabCon 3D, there was one guy who was doing like art printing and procedural printing. And he had like a Burning Man exhibition. Or exhibition Burning Man showpiece, or whatever you call it. And he was also using Rhino and Grasshopper, I think, specifically to do like procedural part generation for those art projects. So yeah, if you're using that, you can do you can't use their G-code generator, but I don't think that's actually a slicer that you can just shove any model into.
Yeah, me neither. Have you ever been working with Grasshopper?
No, never.
Because I have seen there is Oliver Brosman. He's a guy that is doing 3D printed shoes, and he's also creating those shoes. How are they called? He's creating those shoes using Grasshopper, and it's impressive what you pre-volve. They're called. And it's impressive what you can get out of that process where you connect those boxes together. So I don't know if it's worth taking a look at.
Yeah. Now, I was going to say, so that the one issue I see with the nozzles is that there is an insulation sleeve that comes with it that actually covers the nozzle extension tube, so you're not getting any heat loss there. But then there is that large slug of brass in this case that looks like it's just out in the open. So you will get quite a lot of heat loss there, and because it is only coupled to the heater block with that long tube, you do get quite a bit of resistance, so that the very nozzle tip is probably going to be 10, 20, 30 degrees colder than what your heater block up top is actually seeing.
But maybe that's not such a big issue. Maybe you need to rise your printing temperatures a little bit more, but due to the amount of time the filament just stays in that hot region, it might also help to melt the material properly and more properly as in comparison to just a small nozzle.
The challenge when you have like such a decoupled system, if you want to, the assumption is you want to keep the very nozzle tip at a constant temperature, because that's that last bit your filament touches. You want to keep that at a constant temperature, but there's such a long delay and such a large resistance to where you're actually regulating the temperature. You're not going to have a consistent temperature at the nozzle. It's always going to lag behind what the heater block is doing, and it's also going to be a variable. And depending on, how much is your fan blowing, how fast are you feeding, because the filament itself and the plastic itself is also carrying energy. It's going to depend on so many different things, and it might be a very touchy setup. Yeah, I don't know. I've not used it. This is just speculation, but
they actually got in contact with me a month or two ago, and they actually said that they're gonna send me one, but so far it hasn't arrived. But we'll see.
If there was like a copper sleeve around that extension part, maybe it would be a bit better. I don't know.
Just due to the thermal mass and the conductivity, or?
Yeah, just because brass isn't that good of a thermal conductor. So if you add some more copper around it, it might just help pull some of that heat down to the nozzle and replace the heat loss from the fan and from just ambient that is happening at that very nozzle tip.
Yeah. Well, yeah. Brass is almost 4 times worse in comparison to copper in terms of thermal conductivity. Interesting. Yeah. Cool. Interesting. All right.
But since we don't have a product yet, like we can't really do any objective assessment of the thing.
The thing that is really interesting. So they're selling the nozzles, which are $34 a piece.
No.
There's
hold on. What did I just see? XYZ up per kit.
Oh, sorry.
Like you can get a single nozzle for $850.
Oh, sorry, $850. Then you can buy a sample G-code for $10.
Wait, what?
On G-codes. Then you can buy a tutorial into path programming for $30. And then in the end, you buy their G-code generator for another $20. So that's $50.
Wait, okay. I thought, okay, those tabs, I thought those were just tutorials. Tutorial, you want to sell your product, obviously you just put a YouTube video there. Okay, but no, to learn how to actually use it, it's another $30, and then you need to. So all things combined, you try it out, you buy the nozzle, you're down like $80. Yep. Okay.
Yeah, we'll see. Maybe someone of us gets the chance to really try it out and see if it's worth for something other than just showing off.
All right.
All right.
Well, let's move on.
Last question.
Yes, go ahead.
Monocle Wheat is asking. Question. Have either of you considered building a DIY 3D printer available on Thingiverse? Examples: Hypercube, Hypercube Evolution, BLV, MGN Cube, ANET, AM8, etc. Have you ever considered, building a DIY 3D printer that is available on Thingiverse?
So, I mean, I have considered building a DIY 3D printer, and I've done so before. I don't know. I've briefly looked into the available printers, like the Hypercube. Obviously, that's the one that always comes up when it's like, hey, do you need a printer to build that one? But no, I've not actually seriously considered building one. I don't know why.
Time.
No, but then again, I have done a full, DIY Prusa Mark II clone, which definitely took more time than just, building a printer that's available on Thingiverse.
Yeah. So, I haven't built one either. I would have liked to build one, but for me, it's just the lack of time and just the flood of 3D printers that I already have, that there is no need for me to print one. I've also heard many things about the Hypercube. Seems to be working really well. But yeah, you need to spend a bit of time printing building those printers. And you already need an existing 3D printer to print the parts for it. But otherwise, yeah, if you're looking for a project, I think it's not a bad idea to work on one of those.
I think I just realized why I've never considered building one, and it probably has to do with the fact that I already have so many printers that, we just talked about the Creality want to send us yet another printer, and possibly this weekend, and when this podcast goes live, it'll maybe already have happened. I'm just going to be taking apart printers because I have too many. I'll be taking apart some of the not so good ones and scrapping them for parts. That when I do want to build a 3D printer, when I do want to take the time, I want it to be something that I made, that I either designed, where I can try out stuff, or where I don't know, want to have something unique. And maybe the fact that it's something that already exists isn't unique enough for me or challenging enough.
Yeah.
I don't know. I know it's a great community project, and it's if you have a list of all the YouTube video ideas you want to do, then it's probably very high up on the list to just build a Hypercube or something. But for me as a 3D printer user, again, like I just have too many machines.
Yeah, well, the thing is, probably all of the plans are available open source. So even though if you wouldn't build exactly one of those, you could still use those as a reference for good ideas and customize them to your own needs. Either make it bigger, make it smaller, make it more sturdy, and things like that. So.
Well, most of the time, if I do have to work through somebody else's CAD files, I always find that it takes a lot of time to get into how things work together and how things mesh together, how they work, to modify it. And if you really want to start modifying stuff, I think you need to have built it before to understand what you're trying to change and why you're trying to change it.
But I think it's probably still better than starting from scratch. If you haven't already built like 2 printers on your own.
Oh yeah, for people out there. Yeah, for me, I mean, I've built more than 2 printers on my own from scratch.
All right. I think that answers that question, and I think that's actually everything for today.
Wow, how long did we record?
140.
140. I guess people need stuff to listen to.
All right.
Yeah.
Tom,
let's see how well this setup worked out. I mean, I still have some editing to do.
Yeah, it's gonna be a little bit different today, probably for the viewers and listeners.
Let's hope it's not gonna be.
I hope it's not gonna be. It's a little bit different behind the scenes, but it might just make the whole workflow for us a little bit easier in the end. Yeah. We'll see.
That would be the dream. Yeah. So anyway, Stefan, thank you for taking the time this week.
thank you, Tom, for being that patient with me, for postponing that recording date over and over
right,
again.
Right. I'd already forgotten about that. Come on, man, family first.
Thank you, listeners and viewers, for staying that long. Leave your questions down below if you want us to talk about them. If you want to support us, there are both of our Patreon links down in the description. And I guess we'll see you, hear you in the next one.
Goodbye.
Goodbye.